Hello students, good morning everyone. In the last class we have discussed about atoms and molecules. Today we are going to discuss about difference between an atom and a molecule. Before going to discuss about that, again I want to repeat. Just normally, atom. An atom is the smallest particle of an element which is made from protons, neutrons, electrons. You have already learned it. An atom is the smallest particle of an element made from protons, neutrons, and electrons. Molecules. We know molecule is the smallest particle of an element or a compound. So it's just normally. A molecule is a group of atoms bonded together by the covalent bonding. In simple form we can say an atom has only one, whereas a molecule may be more than one atom, which is bonded together by the covalent bonding or attractive forces called chemical bonds. The atoms in a molecule are held together by chemical bonds. Okay. So now we are going to discuss about difference between an atom and a molecule. Atom is the smallest particle of an element. Molecule is a group of two or more atoms combined together by an attractive forces called chemical bonds. So the size of a molecule is bigger than the size of an atom. Atom consists of a nucleus. We have already learned that a nucleus contains protons and neutrons, which is this one, and the negatively charged particles called electrons move around the nucleus. So the atom consists of a nucleus. In nucleus, protons and neutrons are there, and electrons. Atom consists of a nucleus and electrons. Electrons we know that electrons are move around the nucleus, which is negatively charged particles. Next one, molecule. Molecule consists of a combination of two or more atoms that may be same or different atoms, which is chemically bound together. Okay. The third one, atom can neither be seen through naked eye nor through magnifying microscope. Means we can't see through our normal eye, or by magnifying microscope also we can't see the atom. While in the case of molecule, we can't see the molecule through our naked eye, but it can be seen through highly magnifying microscope, because we have already known it is bigger than the atom. So we can see the molecule through highly magnifying microscope. The next one, atom cannot be further divided. We can't divide an atom, but molecule can further be divided to give individual atoms. We have already learned that molecule has two or more atoms. So we can divide a molecule and get the individual atoms by which it is made up of. The fifth one, atoms may or may not have an independent existence. Atoms cannot exist independently. Sometimes they exist independently, atoms exist independently, but sometimes not. Some atoms can exist independently, some atoms cannot exist independently. So, may or may not have an independent existence. For example, an atom of oxygen has no independent existence, but an atom of helium has independent existence. Both are atoms, but oxygen has no independent existence, but helium has independent existence. Okay, so atoms may or may not have an independent existence. But in case of molecules have an independent existence. For example, the one molecule of oxygen has independent existence, and we know molecule of oxygen has 2 atoms of oxygen. When 2 atoms of oxygen are chemically bound together, then the molecule of oxygen has independent existence, but the atom of oxygen has no independent existence. The last one, atom has nuclear bond or attraction within it. That is, it involves electrostatic attraction between the positive nucleus and electrons. Atoms has nuclear bond or attraction. That means we know in an atom nucleus is there and electrons is there. Protons are positively charged particles. Neutrons have no any charge, but electrons have negatively charged particles. Electrons are negatively charged particles, so the electrostatic attraction between the positive nucleus, because in nucleus positively charged particles are there, that is proton. So positive nucleus and electrons are attracted by, there is attraction occurred, that is electrostatic attraction. In the case of molecules have a chemical attraction. Atoms has nuclear attraction, but molecule has a chemical attraction or bonding between the atoms. That is, it involves a single, double or triple bond between the atoms. We know molecule has 2 or more atoms, and these atoms are bonding by chemical attraction, due to chemical attraction. Okay. The next one, chemical formula of elements. We have already discussed about the chemical symbol, how we can represent. We have already discussed about the symbol of an element, the different symbols of different elements we have already discussed, and the symbol of an element represents one atom of the element. The symbol only represents one atom of the element. Today we are going to discuss about chemical formula of an element. The chemical formula represents one molecule of the element or a compound, and we know molecule may be has a group of atoms. No, molecule is a group of atoms. So the chemical formula helps us to know about one molecule of the element or a compound, how we can represent. The chemical symbol for the element oxygen is what? That is O, which represents one atom of oxygen. But chemical formula of oxygen gas is O2. That means it represents one molecule of oxygen. And from this chemical formula we can know that one molecule of oxygen made up of two atoms of the oxygen element. So the next one, the number of atoms present in a single molecule of an element is known as atomicity. How many number of atoms are present in a molecule, in a single molecule? That is called atomicity of an element. In this case, oxygen gas, how many numbers of atoms in the single molecule of oxygen? That is 2. So the atomicity of oxygen gas is 2. Some elements are there which exist as a single atom, means they can exist independently, and those type of elements are called monoatomic elements. And basically inert gases and metals are monoatomic elements. The elements which exist as a single atom, that is monoatomic molecules. Inert gases and metals are monoatomic. Molecules, some examples of monoatomic molecules are sodium, that is Na, potassium, K, copper, Cu, iron, Fe, mercury, Hg, magnesium, Mg, silver, Ag. These are the examples of metals. And inert gases we know. Which are the examples? Helium, neon, and many more. No, we have already discussed about that. So, the molecules of elements with two atoms are called diatomic molecules. We have already learned that in a single molecule of oxygen has two oxygen atoms, so the atomicity is 2, and the molecule of oxygen is a diatomic molecule. The molecule of oxygen is a diatomic molecule because it has two atoms. Similarly, molecule of hydrogen is also a diatomic molecule because it has two atoms of hydrogen. We can represent hydrogen gas by H2 symbol, that is chemical symbol. Some other examples of diatomic elements are chlorine, nitrogen, bromine, iodine. If the molecule has 3 atoms, then that is triatomic molecule. And an example of triatomic molecule is ozone, not oxygen. In your book that is given oxygen, but that is ozone. And ozone has 3 atoms of oxygen. Ozone is made up of 3 atoms of oxygen. If the molecule has more than 3 atoms, then that type of molecules are called polyatomic molecules. And an example of polyatomic molecule is a molecule of phosphorus contains 4 atoms of phosphorus. That means its atomicity is 4. Okay. So other examples of polyatomic elements are sulfur. Sulfur molecule has 8 atoms. A single molecule of sulfur has 8 atoms of sulfur. Okay. Thank you.